Alright, so back into our car computer as a DSP explanation video series. Where are we up to? We're up to the flow from the input, which was the iPad, digitally sent through the input chain, then split or repeated to all of the amplifier output chains with various crossovers to filter out the unwanted frequencies for those sets of speakers. Let's look at the 8-inch. No, let's go back to the high mid dot audio. And now I'm turning off the tweeters, subs, low mids. We're just listening to the high mid. As you can hear the low mid there. Back to the high mid. Right, so we did crossovers enough. So after the crossover, the next one is my preset selection chain. So the high mids go through the first correction EQ. So they go through it here, correction first, 1, 2, 2 per side, and we'll get to them later, because logically, first thing you do when you're setting up a multi-way audio system is you get all your delays in the ballpark. And so what I've done is set up a rough delay per channel here. And this delay plugin you can set it in coarse and fine. So coarse I've set about 6.28 milliseconds, and I guess there's the fine adjust at the bottom. And the way I've come to that number is using an analyzing program, which we'll cover in later videos. So analyzed all the delays for all of the amp outputs, and you dial them in here, and my analyzation software can help me know that I've got them in the rough ballpark. And then there's also a left and right delay, which you can, as you're working on each channel and each set of speakers, you can individually adjust an extra amount of delay for the left and right. And still, when you're EQing and looking for the right magnitude response, you're also affecting phase. So you're always adjusting the micro adjustments here in microseconds. And it also tells you the distance here, which is a little bit redundant because of all of the latency that accumulates in all these plugins. So as long as the combination of the system is looking at the right delay on my program, I don't really care what the numbers are, as long as the final signal reaching the seated position is the correct amount relative to each other. So we've got the left and right fine adjustment in the delay. What would come next? I guess next I always look at the EQ for that channel. So in this case, if I turned off the right channel, I was just listening to the left channel. The EQs that I've used in this program are specifically chosen because of the speaker mounts I've decided to go with and the positioning. So that's through this coaxial device and then bounced off the window. And in doing that, you're getting a lot of impedance increases, reductions, reflections, resonances, and different phase issues, but I've managed to circumvent all that, or correct all of that, using this plugin, which is the freeform equalizer. You can actually draw with your finger or a mouse any curve you want, and the actual EQ is this actual black line. So this is a negative, this is a little positive, there's a slow dip and some more positives, and then some more negatives. Now, the target curve is the red, and this target curve was measured using pink noise through the crossover digitally into the desired target curve, and then using a microphone I have measured from the seating position an average moving mic technique to get the blue curve. And so if you just looked at the blue curve and just try not to look at the rest, you can see that the impedance of that 3-inch mid is very... we won't forget everything below there. So there's a lot of impedance in say the 1K to 1.5K, and there's a lot of energy that the speaker can make in this 500 area, and then these little peaks from the cabin and the speaker placement and the housing of the coaxial unit. Anyway, so the black line is correcting for those. You can see how there's a dip. There's a dip there that corresponds to the blue peak. And hello, camera. Right, so this is one pass. The maximum correction here is set by this one here, and excuse me for a sec. Yeah, so I was saying this range is the effective range from here to there, and what the black line is doing. So you can literally read, so it's doing almost 1 dB bump near the crossover, and then it's pulling down to almost nothing in this range, the sweet spot of the speaker's driver ability, and then it's adding about, I guess that's exponential maybe. Oh no, it's 12, not 1.2. So yeah, 10 dB, 0, 12, 13, 14, 10, a couple, 15. So that's the kind of dB range that this plugin is doing. And it's set to minimum phase, and this is the other thing about this plugin, is it's a linear phase plugin which has an algorithm called minimum phase. See, a linear phase plugin would attempt to change all these magnitudes without affecting phase, and that would be nice in some circumstances, but in this circumstance we want it to change phase as well. Instead of using an IIR graphic equalizer or plugin or whatever, this curve would create a lot of phase rotations. So the minimum phase algorithm is an algorithm which changes the phase a little bit, but still keeping everything in FIR processing. And the sound here, I've chosen to use a low quality because I found there's a lot of artifacts when you go up to high quality or ultra high quality. This is the lowest setting, has less accuracy in these lower bands, but that's okay because we don't hear those bands in this speaker set. But having said that, you can see that the resolution of this equalizer is at least, that's 200 to 500, and there's at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, there's at least 16 bands of change within that half an octave, so I guess you could say an octave is 200 to 2K, so at least 16 bands in a third of an octave there. What else have we got to say? Yeah, so we're doing the minimum phase because we want to correct phase, because some of these frequencies from this contraption have been reordered in the space in the cabin to get to our ear at a different time, so we wanted to recorrect that. So I was going to say 1 EQ was great, but 2 EQs is better. And we're running an i7 Intel processor, so why not? Let's do 2 of them. Anyway, so you can see that this process here was a direct copy of the first process. This one is like, hey buddy, this sounds really funny. And the second plugin is, let's try and fix that a bit better. Using the same mic technique in the similar location, same location, second time. So let's just turn them off. This is the sound of the first plugin. Getting it to our desired bandpass with the orange the first time, second time. So second time it was measured, you can see the blue here, and here's the blue here from the first time it was measured. And it's moved a lot of the frequencies closer to the red line. You can see we're still lacking here by, I guess, the units of 12, so we're still lacking by maybe 10 dB in this little dip here. And it's tried to add maybe 7 dB. Have I got that set to 65? Yeah, so it's still adding some more to get it to the desired flatness for this speaker group. And you can see that past the cutoff point, our desired response is way down here in the theoretical world, and this is just noise for this stuff there. And it hasn't tried to boost that at all, which is interesting. It's tried to keep it down. Maybe I manually flatten that area, but this is well beyond the cutoffs range anyway. So that was EQ. We've done delay. We've done EQ. We've done. I guess we don't have to look at phase just yet. And so that would happen for the left channel, for the right channel. Delays would be set so that the imaging of whatever the music is feels right here, or out here more specifically. And I guess we'll talk about getting the EQ right for the combination of frequencies. So here we're adding low mids, bass, tweeters. So we'll talk about how we did the final EQ and phase in another video.